Exercise 5, SolidWorks. In this exercise, we're going to take a look at the bottom-up assembly method using existing parts that are taken either from a library or parts that were just built somewhere, and bringing them in and attaching them to each other using mates. And when we're finished with it, we should be able to go ahead and apply what's called dynamic assembly motion to get everything to spin around as if it were somewhat simulating real conditions. It's not including kinematics so much as it's more just dynamics. So let's begin. I'm going to start with a new part file, a new assembly file. Click on assembly, hit OK. And over on the left here, we get to begin the assembly. Just go to browse. And it should be directing you, or hopefully you're directing yourself to the exercise 5 files. Now, to get these part files, you have to go to vertanu1.com. That's V as in Victor, E, R, T, A, N as in Nancy, U, X, and number 1, just the 1 at the end, .com. And go to the SolidWorks Basics, and under there you'll find exercise 5 parts. Now be careful, there's lab 5 parts too, but that's a lab. It's just to continue on with this, there's a different set of parts. So once you're there, what we're looking to start off with is a sheet metal bracket. So click on the sheet metal bracket, hit open, and hold on a second. I've got to shut down the other file here. Just got too much going on. Okay. Assembly, browse. Okay, you'll see the bracket appear. Now, rather than just dropping it anywhere, sometimes you get lucky and you actually land, your pointer lands on the origin, which is invisible right now on my screen. That's what we actually want to do with this particular part, is get it on the origin. If you can't see it, the easiest thing is just hit the green check mark, and it will automatically drop into the origin. This little F in parentheses that you see here, where it says sheet metal bracket, the F indicates that it's fixed. We do want the very first part in this case fixed. That means it will not move whatsoever. What's going to happen with the additional parts once we start adding them? Those parts will spin around this part or inside them. And if you don't have anything fixed, all of them will just spin around arbitrarily. So by default, SolidWorks always fixes the very first part. If for some reason you want to change that, you can always right click on it. There's a float option. I don't want you to do that now. We actually want this to be fixed throughout this lesson, but just know that it's there. Okay, let's begin. Under Insert Components here, if you hit the little arrow, you'll see that there's Insert Components, New Part, New Assembly, Copy with Mates. The New Part, New Assembly, that's what we call top-down assembly modeling. We actually could construct geometry using a skeleton of sketches or whatnot and generate the parts inside of the assembly based off of other parts and geometry. Therefore, they update together. This is a much easier method for a new user. Actually, the top-down method is where all the power is at, but we cover that later in exercises 9, 10, and 11. But we're just going to start with bottom-up. So we're going to go to Insert Components, go to Browse, and we're going to locate the next part, which is the yoke mail. Hit Open. Just click to drop your part somewhere around here. If you want, you could actually go to an isometric view. Like here, I've set to trimetric actually. You can go to isometric. Either one is fine. Okay, we're going to begin by mating these parts. You could go to the paperclip tool here, and now you select that salmon colored surface there, the pink, and then the pink surface here. Be careful, SolidWorks will let you select edges. Edges are very useful for mates, but we're going to avoid using them in this exercise. Later on, they will be covered. But in this case, we just want to stick with faces. And once those two are selected, you'll see the part moves into position, and it's actually aligned concentric. Now, this right here indicates that that little button is concentric. There's other options like tangent, and perpendicular, parallel, at a distance, or lock. We don't want any of those except concentric. SolidWorks was smart enough to know that that's the most logical answer here. Let's hit the green check mark. In fact, let's hit the green check mark over here. Now what we can see, if we grab this part, we can actually move it. You click on it, drag it. Essentially what we've done is we've removed some of the degrees of freedom. All it could do now is move up and down and rotate. It can no longer move in the X and Y directions. So from there, let's just drag it down a little bit. And we're going to continue to add some additional mates. By the way, there is the Move Component tool. That's a nice tool. That should do exactly what we did earlier, where we just grabbed it and gripped it. But inside here, there's also free drag along assembly, delta, XYZ. We'll go through that in just a little bit. There's also collision detection, physical dynamics as well. But we'll cover that shortly. But let's right now just go to Mate and see this light gray surface at the top here. Click on that. Now with your middle mouse button depressed or your scroll, you know you can push that down and move your pointer up. Should expose this underside surface of the flange. Click on that because we want our faces to go coincident. And again, SolidWorks makes the right choice for us, coincident being that choice. Go ahead and hit the green check mark to apply. Let's hit the green check mark over here in the upper left, and now we could go to Move Component and click on this top surface and drag it around. Now, we didn't have to go to Move Component, we could actually just click on it and drag it around, but just so you familiarize yourself with some of those tools as they're useful. You can see that it's removed the degrees of freedom for the vertical movement up and down. Okay, let's introduce another part here. So we're going to Insert Components, Browse, and now we're going to look for the spider hinge. Click on that. Hit Open, and just somewhere around here, click to drop it. Okay, just some of the other techniques or technology that's built into here. If we go to the Move component, I'd like to share with you some of these things. Right now we're on standard drag. There is rotate, and you can rotate around the center of the object, things like that, but we actually don't want rotate so much as we just want to show you collision detection. Now with collision detection, you can have it to test collisions between all components, which can be demanding if you have a lot of parts on the screen. So sometimes you might want to select the individual components by clicking these components and limit the amount of resources that the computer has to take up to try and calculate those things. We want it to stop at collision, and we'll leave the other drag part only alone. But now if we go over here, in fact, actually it's still set to rotate. Let me cancel that. Let's go back to Move Component, Collision Detection. Now drag it. And unfortunately, my computer seems to have locked up a little bit here. If we move it there, you can see it moves. Again, let's try collision detection. There we go. It's a little slow on the uptake. Right now I'm processing a video, so it's there's not a lot of resources on my computer. But anyhow, you can see as it hits, it actually pings, and you hear a little ping noise. As it strikes it, it shows where collisions are taking place. There's also physical dynamics. Physical dynamics is a little bit different. It's kind of like the domino effect. You could actually push one part with another, or imagine like a pool table. You had a cue ball, and you grab the cue ball and drag it along the table, and whatever balls it hits, it moves them out of the way. The only thing it doesn't accommodate for are several things, like the inertia or momentum and things like that. So when you push them, they just move out of the way, and that's it. They won't continue to move. There's no factors like gravity or things like that that are in there. There are packages for kinematics and dynamics that you can do that type of a study, especially in the SolidWorks simulation tools. Okay, so let's move on here, and I'm going to turn off physical dynamics there. Okay, I kind of moved it by accident, just to show you here. If you go to rotate component, you could rotate it around the centroid, however you want. But let's get this locked in. So we're going to go to the Mate tool, little paperclip up here. Select this blue hole, the actual cylindrical face of the hole, not the flat. and then select the hole here, the blue hole. It should align itself and hit the green check mark. Now your part might be over here, it might be back here, but be aware should be aligned concentric to that hole, and it always positions itself as such. It's almost like there's an imaginary rod sticking between them. But now let's go ahead and select the blue face of the pin, the flat blue face, and now you have to select one of the blue faces on the inside of the yoke. Now the question is which one? Well, you can select this one. My recommendation is to select this one on this side so it goes in alignment with it. Now there is an aligned and anti-aligned, or over here you can flip it sometimes, but sometimes you run into little error messages from time to time if it's over constrained or something. So I just like to avoid it altogether. Just hit apply, make sure you get it right the first time. But if it's flipped the other way, go ahead and try using that, the aligned versus anti-aligned. Okay, let's hit the green check mark, and you can see that we can now move and pivot this part inside there, and this rotates. Let's bring in our next part. Go to Insert Component, and actually you do have the ability to use Explorer too. Microsoft Explorer, find the parts, and drag and drop them in. You don't always have to use this method. Now I'm going to go ahead and I'm going to go to the find the yoke female. Open that up, drag it in, and let's start establishing mates. Click on the paperclip here. Select the cylindrical hole, the red hole here on the leg of the yoke female, and then select one of the holes near the red face on the spider hinge to align that. Hit the green check mark. It should automatically go concentric. Now select this red face on the spider and this red face on the inside of the actual yoke. Hit the green check mark to apply. Finally, select that little green underside surface there, at the bottom of that plunger, and then rotate around until you select the pale green face on the bracket. Now you might get an overdefined mate type. The reason for this is that in this case SolidWorks wasn't smart enough to select what we really needed. In fact, there's a little distance gap between those faces, so coincident it wants to go face-to-face contact. It can't do that because there's other relations constraining up here at the top. So this is where you could use parallel, and the parallel should align it. There it is. Now, if for some reason it doesn't work and you keep adding mates, be very careful not to compound mates. In other words, if it's not working the first time, stop, delete it, or undo it, then add your next mate. Over here in the feature tree, you'll see the two little paper clips of mates at the bottom. If you hit the little plus symbol, you will see all the mates that have been added. If there's some of these that are lit up in red or yellow, that's an indication that there's something wrong with them usually. And you could right click on them and you have the ability to edit those features. Here it will take you back. You could change it from parallel to perpendicular or coincident, whichever one you think you need to do if it is wrong. Sometimes it's just easier maybe just to delete it or delete a whole series of them if you've compounded them by accident. You just click on it, you hit the delete key on your keyboard and they'll disappear. Anyhow, that's one thing. You can also do this. You could right click at the top of the assembly and there's actually tree display, and you have the ability to show the mates that are dependent, view mates and dependencies. And what that does is when you hit the little plus symbol next to each part, not only does it show some features here, but it also shows the mates that were established with that individual part. I like that sometimes, but other times I think it's a little too much information. I sometimes just like it all categorized in the mates folder at the bottom. So I'm going to go back to view features and see when we go back there. You'll just see the features there for each individual part. It's whatever you prefer. Okay, let's go ahead and go back to Insert Components, go to Browse, and let's find the red pin. Open that up. drag it over here, and we want that to go into the red hole. So go to the Mate tool, or let me show you another trick. You could hold Alt on your keyboard, the ALT, hold it down, grab the surface with your left mouse button that you want to mate, and drag it to the surface you want to mate it to. And it should go automatically in. In this case, you can see the little symbol to the right of the pointer of concentric. And you can release the mouse button first, and then release the Alt key. And just verify it's concentric. Hit the green check. This next one, the tangent mate, doesn't always work very well that way. So I just like to add it in manually with the Mate tool. Go select this end face of the pin and this dark gray face here, the cylinder, and it should go with tangent by default. Hit the green check mark. Let's go to Insert Components again. Go to Browse and find the blue pin. Now you're going to need two of these blue pins. Let's just drop one in over here first, and then I'll show you how to add a copy. Hit Escape a couple times on your keyboard to make sure you don't have anything pre-selected. Hold Control, grab the blue pin with the left mouse button. Now holding Control, you could drag off a pin. In fact, you could actually even mate this one if you wanted to. But I'm going to drag it over here on the far left side and release it. So now I have two pins. So that's one way. You can also grab them from the feature tree and holding Control drag them in as well. But let's go ahead and mate these. Go to the paper clip. Select the cylindrical face of the blue pin and the blue hole. Green check mark. Select the end face of the pin and push it in by selecting the gray face on the yoke it's mating to. Let's do that on this side now. Select the cylindrical face of the pin. Select the hole. Hit the green check mark. Select the end face of the pin and then select the cylindrical gray face on the yoke. Now if it needs to be flipped, you do have a flip mate alignment. So you can flip it around if it's on the wrong side. Hit the green check mark. And the green check mark again. Okay, now there's some additional parts we need to add. If we rotate this around, let's test it out first. If you click over here, go to trimetric, and you can see. If you grab any part of this, the top here, you can just drag it with the left mouse button, make small little ellipses with your pointer, and you can see it rotate dynamically. What I'm going to do is I'm going to rotate it so I can flip it around. Now under here, there's some set screws that we have to add. So I'm just going to add one, and you can add the rest for practice. I'm going to go to Insert Component, Browse, find the fastener, hit Open. And your fastener may not show these the thread that's on there. The thread is purely cosmetic. I think the ones that I uploaded to the web page do not have the cosmetic thread on there, so don't worry. It just has a picture on it, is what it is. Let's go to Mate. Select the cylindrical face of the pin where the thread is showing up. This one. Select the hole that you want to drop it into. Make sure it's flipped the proper direction so you can see the opening there. Hit the green check mark. Now select the end face to this flat face to lock it in. And like I said, I'm just going to do one, but you could try the other three. It's good practice for you. Alright, and finally we're going to introduce a sub-assembly. Sub-assemblies, when you go to Insert Components, the same method. You go to Browse. The difference is when we look here, you'll see the sub-assembly here. It's just called actually Handle Top. That's not the right one, I'm sorry. It's not showing up. Why would it not show up? Take a look down here. Some of you might actually have this set up differently. But if you're not finding a part or an assembly that you're looking for, make sure that this is set to what you're looking for. I just prefer to go with all files because that way I can see them all. Sometimes though it's a cluster of choices. You might want to limit it to assemblies only. In this case we can see the sub-assembly. But I'm going to go with all files. Now we're looking for the handle. Click on the handle, hit Open. taking a bit of time here. Let's just drag it up there, up above. You could always move it up there if you want. Let's go to the Mate tool and select the cylindrical face. SolidWorks doesn't look at the different diameters with cylindrical faces. It doesn't matter if it's smaller or larger. They're going to basically go by the center line of each. So click on both of those to align it. Now these yellow surfaces here need to be aligned. This little flat yellow surface here needs to be aligned to this. Click on that. And hopefully it should align itself properly. If not, remember you have the ability to flip the Mate alignment. Hit the green check mark. And now there's a little green underside surface here. Select that face. And then we want that to be merged to the top surface, but we don't want it to touch the top surface. We actually want a little bit of a distance gap. So when you select it, it automatically goes to coincident, which is not what we want. But if you go over here to the left, or even if you go over here to distance, either one is fine. Click on distance, and watch this. Notice it's in inches on mine. But let's say you knew what it was in metric, but not inches. So like we want it to be 1 millimeter. Now 1 millimeter is equivalent to 0.0393 inches. But if we don't know that, we could type in 1 and lowercase mm for millimeters. Hit enter, and it will automatically update to 0.0393. And there's a little bit of an offset. In fact, we could go to 0.5 mm to get it in there a little tighter. You can see the distance gap between the two. And that's how you could apply a distance between them. And now the test. Let's rotate this around a little bit and see if it all moves together. Hit the green check mark on Mate to get rid of it. You're done with Mates. Let's save this too. Let's go to File, Save, or Save As. Either one's fine. And I'm going to save to my desktop, and I'm going to call this the E5 assembly. Hit Save. Alright. Grab this little handle and try and drag it in these little elliptical manner. And you can see if it rotates dynamically. If it all rotates together and nothing is flying out the sides or locked up, you've done it correctly. And also just be aware with your part files, if you're doing the top-down method, if you want to keep the part files together, there is an option. There's a couple options for saving everything a certain way. I could go to Save As. Let's say rebuild here. Let's say I wanted to save this in a separate folder, and I wanted to take all the parts with it. This is kind of neat. I could just write out here, right click, new folder. So I'm on my desktop. I'm going to call this the EX5 for exercise 5. I'm going to double click on that folder. Now, if I were just to hit save right now, it would just save the assembly file. But those part files are needed for the assembly to exist properly. And sometimes if you are transferring files from one computer to another, if you don't bring these over or send them to someone, all those other part files, then they might not be able to open the assembly. They could see a preview of it, but they can't actually open the whole thing and make a drawing of it. So here's a little way you can do that. There's a references button down below. Click on references, and you'll see the paths where all these are located. Just go to browse. Now, you want to find that EX5 folder we just created. You click on it, hit OK. That means that it's going to send all the copies of all these parts and sub-assemblies to that folder for us. And then you just hit Save All. And now it's made copies of all of it. That could be a good thing. And that could also be a bad thing, because if someone makes a change to the part where it was originally located, it will not update on here. But you can have the ability to reload and replace those parts, so it's not critical, but we'll cover that at a later date. And that concludes exercise 5.